Okay, good morning, everyone. As I discussed with you, these are the extra classes schedule of extra classes. Monday, 1st of January. Lesson vector. Okay, this is the lesson. Then same day, Monday, 1st of January, 7 p.m. to 10 p.m. algebra. Last lesson, okay? Every 5 days. Vacation period. In the vacation period, every Friday, from 8 to 12, 8 a.m. to 12 noon, we will discuss vector. We will discuss vector. Vector match. I think we can complete vector lesson from today's class and tomorrow's class and the first class of Friday. So we can complete this the vector lessons from these 3 classes. Then I will start after completing the vector lesson. I will start equilibrium. Okay, equilibrium of forces. Then the afternoon lesson will be dynamic. One p.m. to 5 p.m. linear motion. Dynamic lesson. Okay. Those are the extra classes and lessons we are going to discuss in those extra class. Okay. Okay. Here's the plan. Now, in Mondays, normally we have a permanent class in Mondays from 7 p.m. to 10 p.m. Puta. So tomorrow will be the last day of basic mathematics. That means algebra. After completing that one, I will start measuring instruments part, theory part of measuring instrument lesson in Monday's classes. Okay. Therefore, Monday classes will be measuring instrument classes after completing this lesson. Okay. After completing this lesson means after the tomorrow's class, you will be learn measuring instrument in Monday's class. Okay. After completing this one, it will be measuring instrument. Okay. So measuring instrument. measuring instrument after completing this one. Okay. Then the Friday class, and in the Sunday class, we will learn vector and equilibrium of forces. Vector, after completing the vector, equilibrium of forces. Equilibrium of forces means it will be not a hard lesson, okay? Because we have discussed a lot of things in that lesson in vector series, okay? Then the afternoon session, you will be learn linear motion. That will be the first lesson of dynamic part of mechanics. Okay, linear motion. Okay, you can take a screenshot. Okay. Shall I erase this one? Shall I erase? Okay. Okay. Shall we move to the lesson? Actually, in our previous class, we were discussing about resolving of vector system. Okay. We can recall that memory. Okay. Suppose we are given resolving of a vector. Resolving of a vector means we can represent a vector. Suppose if we are given a vector, we can represent that vector using two perpendicular components. We can represent this vector using two perpendicular components. This is f cos theta, this is f sin theta. Okay. If we can represent a vector using two perpendicular components, that will be called as resolution of this vector. We have discussed that part in our previous lesson. These two components, the resultant force of these two components is equal to F. Okay. Therefore, we can when we are resolving F force. So if you have if you know the angle, if you know this angle, the component into this angle side, that means this side, that means this is the actually adjacent side to this angle. The adjacent side of to this angle is cos theta value, will be a cos theta value. The other side will be a sin theta value. Okay. You can remember that thing. Likewise, the adjacent side to this theta angle will be a cos value, other side will be a sin value. We have discussed that thing. Okay. Then suppose we are given more than one vector. That means a vector system. Suppose we are given a vector system. F1, F2, F3. Likewise. Suppose we are given a vector system to resolve. So if I want to resolve a vector system, definitely I had to resolve these three vectors one by one. No, I have to solve F1 first, then F2, after that F3. What will happen when I'm resolving these vectors. When I'm resolving these vectors, you will have a x component. You will have a component to x direction from f1 and f2 and also from f3. No, you will have three x components. No, from f1, from f2, and from f3. Okay. Likewise, when you are resolving this vector into y direction, you will have a component from f1, from f2, and from f3 also. No? Therefore, when we are resolving a vector system, you will have more than one force or more than one vector in x direction as well as one y direction. Okay. Resolving means we have to reduce the number of vectors into two perpendicular components. Okay. What is that? Resolving means we have to reduce the vector system into two perpendicular components. But now I have more than two components. No? In x direction, there are three components. From f1, then from f2 will be into this side. F1 means component of f1 into x direction, in x direction. F2 means xf2 means component of f2 in x direction. Then f3, xf3. If you resolve this one, it will be in this direction. That means if I resolve a vector system, I will have more than one vector in x direction as well as y direction. So I had to reduce these three vectors into one vector. How to do that? If you want to reduce this vector into one vector, how to do that? I have to take its resultant, no? I have to take it resultant, no? If I want to represent a one vector instead of these three vectors, that means I have to take it resultant vector. Therefore, once you resolve these three vectors separately, you have to take the resultant vector in x direction as well as y direction separately. Okay. So you have to take the resultant force in x direction, then in y direction separately. So once you get the resultant force in x direction and y direction, the entire vector system will be reduced into two perpendicular components. One component is in x direction, other component will be in y direction. Okay. That is the way of resolving the vector system in x and y directions. Okay. Did you understood? Did you get my point? Everyone, I need responses. Thank you. Thank you, Buddha. Okay. Okay. That is the thing we were discussing about in the last week. So I have to give a note about that. Okay. Write a note. Okay. Write a note. Suppose I think this figure was drawn, no? Okay. Suppose there are three forces acting on point O. There are three forces acting on the point O. Acting on point O. if we need to resolve these forces, we have to resolve them. We have to resolve them one by one, one by one. If they are resolved, resolved in x and y directions, separately, if they are resolved in x and y directions separately, there will be 3 x components and 3 y components. There will be 3 x components and 3 y components. In another paragraph, so in order to reduce the vector system into 2 perpendicular components, please give me minutes. What was the last sentence, Buta? Can you tell me?
So in order to reduce the vector system into 2 perpendicular components.
Thank you. 2 perpendicular components. We have to take the resultant vector. We have to take the resultant vectors in x and y directions separately. We have to take the resultant vectors in x and y directions separately. In another paragraph, sorry. In another paragraph, therefore, we have to add the resolved components. Therefore, we have to add the resolved components in x and y directions separately. In x and y directions separately. To reduce them into a single vector in each direction. Write in another paragraph. So we have to define the positive direction. We have to define the positive direction. in positive direction in each x and y axis. Then then the components into positive directions can be considered as positive vectors. while the others while the others while the others can be considered as negative while the others can be considered as negative when adding them Okay. Shall we do an example? Question number 3 in the way. Okay. Here you are given 50 root 3 Newton. The angle is 30. 60 root 3. Angle is 30. 100. This angle is 60. 90 root 3. This angle is 60. Okay. Look at the board, everyone. Everyone, look at the board. Suppose you are given this kind of vector system to resolve in x and y directions. X means this direction and y means this direction. Okay. So, as we discussed earlier, if you are given this kind of vector system to resolve, you have to resolve each and every vector separately. Okay. Then there will be 4x components. No, 4x components. As there are 4 vectors, you will have 4x components and 4y components. So then you have to reduce that 4x components into 1 x component and 4 y components into 1 y component. Then that is the answer. Okay. Okay. How to take the how to reduce that one? How to reduce the x components into 1 single component? You have to take the resultant force of that these 4 x components. Therefore, the first thing you have to decide, you have to define the positive x direction. Okay, you can take either this way or this way. Okay. Suppose I am going to take this direction as the positive x direction. Okay. Therefore, if any components in this direction, that means into the right hand side, then those components will be positive x components, while the others will be negative x components when they are adding each other. Okay. Then you can get the summation or resultant force in x direction. So how to do that? If you want to take the resultant vector, in x direction, you have to decide the positive direction, then take the addition of each component. First, you have to resolve this one. Take the resolved component of 50 root 3 in x direction. If you resolve this force into x direction, look at this. If you resolve this component into x direction, it will be the cos, no? Because cos 30 is the adjacent angle to this side. Adjacent angle. So this will be cos value. So 50 root 3 cos 30. Cos 30. It will be a positive value because I have taken the positive direction into the right hand side. Therefore, it will be positive value. So I have taken the x component of this force first. Then take the x component of this one. Once you take the x component, please take a mark. Okay. Then you can think that actually if once you take the x component, please take a mark. Otherwise, you will take it again. Okay. Then you have to take the x component of this force. Look at this. You know this angle is 60. So this angle will be 30, no? This angle will be 30. So you can consider either this angle or this angle. When you are resolving this force into x direction, you can consider either this angle or this angle. If you want to consider this angle, this is not the adjacent angle. This is not the adjacent angle. Therefore, you have to take 90 root 3 sine 60. Or if you want to take this angle, this is the adjacent angle. This will be adjacent angle. Therefore, you can consider 90 root 3 cos 30. Cos 30 or sine 60. Both are same. Okay. Okay, I will take it as sine. Plus because you can see if you resolve this force into x direction, if you resolve this force into x direction, if you bend this force, bend this force into this direction, it will be in positive direction. Therefore, 90 root 3 sine 60, it will be positive x component. Now, this force is considered. Now go to other force. 60 root 3. 60 root 3 cos 30. It will be cos 30, but it is in the negative direction. It is in the negative direction, so it will be negative. So minus 60 root 3 cos 60. It will be negative. And finally, you can take this force, resolve this force into y direction, sorry, x direction. So it will be negative 2, no? Because once you resolve this force in x direction, it will be in negative direction. So it will be negative force minus 100 root 3 sine 60. Sine 60 or cos 30. Both can be considered. Both can be taken. Okay. Because if you want to consider this angle, it will be the adjacent angle. So if you take this angle, it will be the adjacent angle. Then the component will be cos. If you take this angle, it will be it may won't be the adjacent angle. So it will be sine. Okay. Now you have taken all the x components in for forces. No, you have taken all the x components. No. You have taken all the x components. Then you can take the summation of these components. Cos 30. Cos 30 means root 3 over 2. Root 3 over 2. Look at this one. Sorry, cos 60, no, cos 30. Third. Thank you, Buddha. Cos 30. It is cos 30. This is third angle. Third one. Angle cos 30. Look at this one. Then Root 3 over 2 here. Root 3 over 2. That means root 3 into root 3. That means 3. 50 over 2 means 25. 25 into 3 means 75. 75 Newton. Plus 90 root 3 into root 3 over 2. Root 3 over 2 again. Root 3 over 2. Root 3 into root 3. 3. 90 over 2 means 45. Therefore, 45 into 3, 135. 135. Do it within your mind, okay? Minus 60 sine 30. Sine 30 means again, sorry, cos 30 means again root 3 over 2. Root 3 over 2 means root 3 into root 3. 3. 60 over 2 means 30. 30 into 3 means 90. 90. Minus 100 root 3 sine 60. Sine 60 means root 3 over 2 again. So root 3 into root 3, 3. 100 divided by 2 means 50. 50 into 3 means 150. 150. 150. So minus 15. Minus 15 minus 15. That means minus 30, no? If you consider these two. If you consider these two, it will be minus 15. If you consider these two, it will be minus 15 too, no? Minus 15. Therefore, my answer is minus 30. Minus 30 Newton. Minus 30 Newton. That means the resultant vector, the resultant x is not in right hand direction. That means it is in the left hand direction. Therefore, this component is in this direction. 30 Newton is in this direction. Okay. Then I can find the y directions to y components in the same way. Okay. Okay. Did you get my point? Did you this one? Did you get this calculation? Everyone, I need your responses. I need responses from everyone. Did you get this calculation? Others? Okay. Thank you. Others? Anita, there. What about others? Okay, thank you. Okay, then this is a third question in the tude. Okay, finding the resultant vector. Find the resultants of vector systems. That is the topic. This is the topic, and this is the question. Third question in the tude. Okay, third question of the tude. Okay, let's write this one. Then I can clean the board and do the next calculation. Mm. Okay. Now we have taken the x component of this one. Then you have to find the y component using the same method. Okay. Okay. Y components. Take this side, the upward direction as the positive direction. Okay. Then first you have to resolve this vector, then put another mark, then you can understand you have taken this vector in x direction and y direction too. So 50 root 3, if you resolve this one into this direction, it will be sine 30 or cos 60, no? In this angle is 60. If you want to deal with cos value, you have to take this angle. This is the adjacent angle. So if you can, if you want to use this angle, it will be 30. Okay. If you want to resolve 50 root 3 into y direction, you have to consider either this angle or this angle. If you consider this angle, it will be the adjacent angle. So the component will be cos. So 50 root 3 sine 30 or cos 60. Both are same. Sine 30, it will be positive because this force, once you resolve this force, it is in the upward direction. So it will be positive. Then take this one and put another tick here. One tick means you have considered it in one direction. If there are two ticks, that means you have taken it in both directions. So 90 minus 90 root 3, if you resolve this one into this direction, it will be cos. It will be cos minus 90 root 3 cos 60. Cos 60. Look at this. If you resolve this one, this was in negative direction, no, downward direction. Downward direction will be the negative direction because I have taken the positive directions as upper direction. So it will be minus. Then this one. 60 root 3. If you resolve this one in y direction, it will be in the upward direction, no? So the value will be positive. The value will be positive 60 root 3, either cos 60 or sine 30. Then again, take this one. If you take this one, if you resolve this one, you can clearly see it is in the downward direction. Therefore, it will be negative. It will be negative. So 100 root 3 negative 100 root 3 cos 60. Cos 60. Cos 60. Because once you resolve this one, 60 is the adjacent angle. It is 60. So all are half, no? All are half, no? So if it is half, this is 25 root 3 minus cos 60 is half, or 90 over half means 19 to half means 40. 5 root 3 plus sine 30 is half, therefore 60 divided by 2, 30 root 3 minus 100 divided by 2, 50 root 3. 50 root 3. Okay, that means from this one minus 15 minus 25, but that means minus 40. Minus 40 root 3, no? Minus 40 root 3. Minus 15 minus 25. Minus 15 minus 25 is 40. Minus 40 root 3 Newton. Minus 40 root 3 Newton means the resultant vector in y direction is not in the upward way. It should be in downward direction. Downward direction. Upward force is negative. That means it will be in downward direction. Therefore, the y component is in downward direction, 40 root 3 Newton. 40 root 3 Newton. Therefore, I can convert this vector system into two perpendicular vectors which are in this direction and downward direction. The x component is equal to 30 Newton, y component is equal to 40 root 3. 40 root 3. Okay. Did you get this one? So this is the answer. This is the answer. You have to resolve this vector system now. Therefore, this is the answer. If you resolve this vector system, the x component is in left hand side. The magnitude of x component is 30 Newton. If you resolve this vector system in y direction, the component is equal to 40 root 3 Newton. It is in the downward way. Okay, I need responses from everyone. Did you get this one? Or if you need any explanation again? Thank you. Others? Thank you. Everyone, I need your responses. Thank you. Thank you. Okay, Pute. So write this one. Write this one, and once you write the once you copy this down, then you can do the second question. Okay, copy this down. මම මුලින් කරලා තියෙන resolving vector එක කියන්නේ resultant vector එක එකේ question එකක් sorry Those are the questions related to me resolving of vectors. If it is okay, so you can start from question number 4, 5, and 6. Please do question number 4, 5, and 6. Question number 4, 5, and 6. Do it quickly. 4, 5, and 6. Once you complete doing 4, 5, and 6, please send me your answers. Okay, shall we discuss? Question number 4, 5, and 6. Question number 4. 40 root 3, that is 30 degree. 60 Newton, that is in 60 degree. And there's another force 30 here. 30 Newton. There are 3 forces, no? Okay, everyone, look at the board. Everyone, I need your attention. In this vector system, there are 3 forces. First one is 30 Newton. It is in x direction. And second one is 40 root 3. It is in this way, 30 angle to the x direction. And this is the last one. Okay. So if you want to resolve these 3 forces in x and y directions, you have to do it separately. Do it. The first in the x direction. So I have taken the right hand side as the positive direction, positive x. You can resolve these 3 forces separately in these direction. First do it. 30 Newton. Look at this one. 30 Newton is in the x direction. Therefore, no need to resolve. It is in the x direction. 30. Then plus 40 cos 30. 40 root 3 cos 30. If you resolve this force into x direction, it is in the right hand side. Therefore, it will be positive. And the angle is adjacent to the x direction. Therefore, it will be cos value, cos 30. Or either you can take this sign system. Then the third force. The third force, if you resolve this third force, look at this. If you resolve this third force, it will be in negative side. Therefore, the sign is negative 60 sin 60 or cos 30. Either can be taken. 60. Look at this one. If you consider this angle, it will be 30. It is adjacent to the x side. Therefore, 60 cos 30. Or if you consider this angle, it is not the adjacent one. So it will be sin 60. Okay. Then again, look at this one. Now you have to simplify this expression. 30 plus cos 30. Cos 30 means root 30 over root 3 over 2. So root 3 into root 3 will be 3. 40 divided by 2, 20. 20 into 3 means 60. Do it at one time. Minus sin 60. Sin 60 means again root 3 over 2. Root 3 over 2. No. You. Come on. Root 3 over 2. It's okay. You have to We solve this only. No? Root 3 over 2. Therefore, 30 root 3. 30 root 3. Your answer would be 90 minus 30 root 3. 90 minus 30 root 3. What was your answers? Hmm? What is your answers? Megavada? I need responses from everyone. If you got this answer, please let me know. If you got this answer, please let me know. 90 minus 30. 30 root 3. No? 30 root 3. Science system. Is my drawing is correct? Yes, it's no? Yes, yes, yes. My drawing is correct, no? Hmm? Okay, okay, okay. Okay, okay. If you if you use the value of root 3, it is approximately 1.71, 1.71 or 1.72, because if you take 1.7, it is equal to 2.89. Therefore, you can take it as 1.71472. So if you add the, you can use that one, okay? Then simplify further. It is okay. I'm not going to simplify further because 90 minus 30 means 30 root 3 means 30 root, it is not equal to 3, no? It is less than 2, less than 3. Less than 3 means this will be positive again. Okay? Okay? The root 3, the answer is not equal to 3, no? If it is 3, then 30 into 3 means 90. So it is less than 3 means the entire expression will be a positive one, no? So my directions won't be changed. Therefore, there will be a force which is equal to 90 minus 30 root 3 here. 90 minus 30 root 3. Then you can find the y component. You can find the y component. Take the upward directions as the positive direction. I had taken both.
Sir, isn't it minus 60?
Sorry? This one?
Yes, sir.
Why? If you resolve this angle, if you resolve this force into this side, it will be in negative direction, Bhuta. I have taken the positive direction at right hand side. So it is opposite to that direction. That means minus.
Sir, but you have put it as plus 60.
No. This is not the one. This is the simplified one of 40 root 3 cos 60. That is this one. This is the component of 30. This is the component of 40 root 3 cos 60. This is the component of this one. This is the minus one. Okay. If you simplify this one, cos 30 equal to root 3 over 2. Root 3 over 2 means root 3 into root 3, 3. 40 divided by 2 means 20. 20 into 3 means 60. This is not this one. This is not this one, okay? This value is the simplified value of this one. Did you get this one?
Okay, sir. Sir, can't we simplify 90 minus 30 as 60 root 3?
90 minus.
Final answer.
No, 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 no. Ah. ඉස්සලා ඉවෙත් ඒකද? No, no, you cannot simplify this one, okay? Because root 3 is another one. It is a third, no. Okay? Therefore, you cannot simplify this one, okay? 90 minus 60, this is not equal to 60 root 3. This is not equal to 60 root 3. That is wrong. Previously, same thing. No. This is wrong, Jasmine. Where we cannot take it as 60 root 3. Actually, I did not understand that one. Okay. Very good question, Puta. This is not equal to this is not equal to 60 root 3. This is something like there is 90 minus 30 into root 3. No, 30 into root 3 means you have to take the square root of 3. What is the square root of 3? It is equal to approximately equal to 1.71. Okay. So the meaning of this is 30 multiplied by root 3. Root 3 means 1.71. I cannot simplify root 3 because it is relative to complex one, no? Because 3 does not have a integer square root, no? Therefore, I cannot simplify this one. Therefore, if you want to simplify this one, this is the meaning of this. 30 into root 3. 30 into root 3 means 30 multiplied by square root of 3. 30 multiplied by square root of 3. What is the value of square root of 3? 1.71. Okay. So if you simplify this one, is it equal to 60? 60 root 3? No. It's not equal to 60 root 3. Okay? If you have this one, 90 root 3 minus 30 root 3, then it is equal to 60 root 3 because both root 3 is a common factor for both value. Root 3 is a common factor for both value. Therefore, you can take it out, then you can simplify 90 minus 60. In this case, root 3 is not common factor for both numbers. So yeah, you cannot say it is equal to 60 root 3. You cannot say. That is wrong. That is wrong. If you want to simplify this one, you can simply substitute this value and do the calculation. Okay. Otherwise, you cannot say it is equal to 60 root 3. This is something like 90 minus 60x. This is something like 90 minus 60x. Can you say 90 minus 60x, 30x? Can you say 90 minus 60x is equal to 60x? Can you say? You cannot say, no. This is exactly equal to this kind of expression. Okay. You can say it is equal to 60 root 3 if there is root 3 in 90 also. Okay. There another is true. Just me.
Okay, sir.
Oh. That's why I keep it as this one, original form. Okay. Then the y component. The y component. The y component. You can first you can take 30. 30 is in x direction. Therefore, y component is exactly 90 degree to the x component. That means there won't be any y component from 30 because it is exactly in the x direction. Therefore, y component of 30 is 0 because it is perpendicular to y direction. Perpendicular y direction, that means cos 90 is 0. Then take this one, 40 root 3 cos 60, 40 root 3 cos 60 or sin 30. Sin 30. It is in the positive x direction, y direction, because I have taken the positive direction as in the upward direction. If you consider it is in downward direction, then it will be negative. Then this one. If you resolve this one into y direction, you can clearly see it is in downward direction. Therefore, it will be negative. Negative 60. The angle is 60. Therefore, cos 60. Cos 60. Then, if you simplify this one, 40 root 3 sin 30 means 20 root 3 minus cos 60 means half, that means 30. 30. That again, if you want to simplify this one, you have to substitute 1.71. 1.71. If you add 1.71, it will be greater than 30. Therefore, this value will be positive value. This value will be a positive value. Okay. Therefore, I can simply say the resolved component is in this direction x. It is equal to 90 minus 30 root 3, and y component is in this direction. It is equal to 20 root 3 minus 30. 20 root 3 minus 30. Did you get these answers? Everyone, I need responses. If you have any comments, please let me know. If anything to clear, please let me know. Yes. Up to 12, okay. If you are anything to 0 comes, no? Look at this. Now 30 is in this direction, Puta. 30 is in this direction. Look at this one. 30 is in this direction. If you want to resolve this one in y direction, this is the angle 90. This is the angle 90. So what is the component of y direction? 30 cos 90. 30 cos 90, because angle between 30 and y direction is equal 90. Therefore, 30 cos 90. 30 cos 90. Cos 90 is 0. Cos 90 is 0. That means there won't be any component in y direction. There won't be any component of 30 Newton in y direction. I think we have discussed this one, no? No. If any force is resolved into a perpendicular direction, then there won't be any component because the angle is 90. Okay, I will give a note. Okay. Okay, write down a note, a special note. Suppose there is a force in x direction. You have to take the component of f in y direction. This is x, this is y. So the component of f in y direction, is equal f, what is the angle? Cos 90, f cos 90. F cos 90. Okay. Cos 90. What is the value of cos 90? Cos 90 is equal to 0. This is equal to 0. So y component component of f in y direction is 0 because it is perpendicular to the y direction. Therefore, there won't be any resolved component of any force into a perpendicular direction. Okay. Therefore, there won't be any effect. There won't be any effect from any force or any vector to its perpendicular direction. That is a very important thing. Okay. Because the perpendicular component of any vector will be 0. Okay. Did you understand? Everyone, I need the responses. Okay. Therefore, if you take any vector, the perpendicular components of it, will be 0. Therefore, there won't be any effect from this force to its perpendicular direction because there won't be any component in perpendicular direction. Okay. Draw this one and this one. Okay. Once you draw this one, please write under this figure. So there is no component of a vector to its perpendicular directions. To its perpendicular directions. Therefore, there is no effect. There is no effect from a vector into its perpendicular directions. Into its perpendicular directions. Okay, fifth one. √3 into 30. 90 √3, 30. 160. 60. 40 √2. 40 √2. Okay. Again, let's do the same way. Take this direction as the positive x direction and resolve each and every forces into that direction. Okay, we'll check. First, take this force 100 √3. Once you take a force, please mark it. Okay, otherwise you will take it again. 100 √3. The angle is 30. That means cos 30. It is positive because it is in the positive direction. Then 40 √2 cos 45. It is in the positive direction. I have taken the positive direction as right hand side. Positive 40 √2 cos 45. Then this one 90. It is negative, no? If it is resolved in x direction, you can clearly see. So bend this force into x axis. If you bend this force into x axis, it is in the negative side. It is in the negative side. Therefore, the resultant will be negative side. The component, the resolved component is in negative side. 90 minus 90 root 3 cos 30. Then again, this one, 100. Look at this one, how to do that? You have to bend this force into x direction. Bend this force. You have to bend this force. If you bend this force into x direction, what will happen? The arrowhead is in negative way. It is in the negative way. Therefore, the force is negative. Force is negative. Therefore, 100 cos, sorry, 100 sin 60. So cos 30. That is the way of determining the direction. Okay. You can simply bend this force. You can simply bend this force into x. If you bend this force into x, what is the direction of arrowhead? What is the direction of arrowhead? It is in the right hand side. No, it is in the right hand side. That means it is in the positive x direction. Positive x direction. Therefore, it will be positive. If you bend this force into x, the arrowhead will be in negative direction. So it will be negative. That is the way of determining the direction of the force. Then again, now you can simplify this one. Root 3 over 2. Root 3 over 2 means root 3 into root 3, 3. 100 over 2 means 50. 50 into 3 means 150. Cos 45 means 1 over root 2. Root 2 to root 2 will be cancelled out. Therefore, answer is 40. Again, root 3 over 2. Root 3 over 2 means root 3 to root 3, 3. 90 over 2 means 45. 45 into 3 means minus 135. Minus sin 60 means root 3. 100 to 100 root 3. 100, no? It's okay. 100. Then root 3 over 2 means that means 50 root 3. 50 root 3. So if you simplify this one, this is 15. 15 means 55. 55 into 50 root 3, no? 55 into 50 root 3. If you consider these two forces, you can clearly see this one is larger than this one. This is 55, no? This is 55. This is 1.7. 1.7 is more than 1.5. More than 1.5. If it is 1.5, the answer would be 75. So it is more than 75. Therefore, this value is larger than this value. Therefore, the answer would be a negative value. Therefore, actual x is not in this direction. It is in left hand side. It should be left hand side. Therefore, the x value in left hand side, it is equal to 50 root 3 minus 55. Negative value of this one. If you want to solve this one, you have to substitute the value of root 3. Then again, you can consider the y component. You can consider y component. If you take this one, it is 100 root 3 cos 60. 100 root 3 cos 60. Look at this one. If you bend this force into y direction, the arrowhead is in upward direction. Therefore, it will be positive. Therefore, 100 root 3 cos 60. Cos 60 because this is 60. Or otherwise, you can say sin 60, sin 30. Then take this one. Put a tick again. If you bend this force into this y axis, the arrowhead is in positive direction. Therefore, the component will be positive. 90 root 3. You can say either cos is sin 30 plus 90 root 3 cos 60. Cos 60. Then take this value. If you bend this force into y-axis, the arrowhead will be in negative direction. Therefore, the vector will be negative 100 cos 60 minus 100 cos 60. Then take this value, fourth one. If you consider this value, look at this, 40 root 3, you have to bend this force into y-axis. If you bend this force into y-axis, the arrowhead will be in negative direction. So, the component will be negative 40 root 2 cos 45. 40 root 2 cos 45. So, if you simplify this one, root 3 over 2, root 3 over 2, root 3 over, sorry, half, no? Cos system is half. Therefore, 50 root 3. 50 root 3. This is again half. Again half, that means 45 root 3. 45 root 3. This one, half means 50 minus 50. This is 1 over 45, that means minus 40. Because root 2 to root 2 will be 1 over root 2. Root 2 to root 2 will be cancelled out. Therefore, it is 40. Now you can add these two. No? Both have root 2, root 3. No? Both numbers have root 3. That is common factor for both numbers. Therefore, now you can add these two. 50 to 45. That means 95 root 3. 95 root 3. Minus 90. Minus 90. This is greater than that of this. Therefore, I can simplify this one into two components. One is in this direction. It is 50 root 3 minus 55. Other one is in upper direction. It's not change. 95 root 3 minus 90. Those are the two resolved component in this vector system. Did you get these answers? Did you get these answers? Or you have something different than that? Please let me know. Answer is correct or not? Answers are correct or not? Your answers? Thank you. Thank you. What about the others? Anita? If you have calculation error, that is not a matter, okay? If you have a calculation error, that is not a matter because it is not relevant to physics, okay? Actually, I need to know whether your resolved components are correct or not. Whether your resolved components are correct or not. Give me the answer. Okay. Others? If your resolved components are correct or not, please let me know. Correct, no? I don't care about your calculation. It is not up to physics, but you have to improve that one. That's up to you. That's up to you. You have to improve your mathematical skills. That's up to you. But I want to know these resolved components are correct or not, because they are relevant to physics. That is the thing. Okay. If you got correct resolve components, then I'm not concerned about your mathematical skills. Okay. Because in A-level exams, these kind of questions are not in the paper. Okay. But you have to resolve process into appropriate directions. You have to apply that knowledge. You have to apply that knowledge because there are a lot of applications of resolving vectors in physics, not only mechanics. It is in everywhere in physics. Therefore, you have to have this knowledge only. You have to have this knowledge only. Therefore, I'm not considering about your calculations ability. It should be improved. It should be improved. Definitely, it should be improved. Okay, but if you have this correct component, if you have correct resolve component, then that is better. Okay. But in your term test paper, especially in first term test, then sometime you may have this kind of questions. Okay, because in term test paper it is very limited questions to ask. No, therefore you may have this kind of questions in your term test paper, in your first and second term test. Mostly you can have this kind of questions. But in A-level exams, you won't be this kind of questions won't be there. Okay, but you have to have the knowledge of resolving process because that is in every area in physics, especially in mechanics. Not only mechanics, everywhere in physics. Okay. Okay. Okay, I'm not going to do question number 6 in today's class. I want to do do it yourself and send your answers to me. Then I will check and correct that one. Okay, I don't want to do it again because it is same thing. Therefore, I'm not going to do it in this class. So please do it as a homework and send that to me. Okay. Again, I think you all have this tut now as a PDF, and you will be receiving hard copies within this week, within next week. So you all have this PDF, this tut as PDF format. So start to do this tut. Okay, start to do the tut. Only essay question. Do not do MCQ questions because I will inform you when you can do this MCQ questions, because I want to do the same MCQ question at once. That means once I complete the vector lesson, then I will inform, please do the MCQ questions, because you have to do MCQ questions at one time. Okay, otherwise you cannot improve your timing. Okay, I will let you know. Okay, actually once I complete the vector lesson, then I will let you know to do MCQ question. Okay, once you actually there are only 56 questions. No? There are only 56 questions. Actually, in A-level exam, there are 50 questions within you have to do within 2 hours. Therefore, you have to allocate only 2 hours. You have to allocate only 2 hours to do MCQ tut. Okay. Therefore, don't do it now. Don't do it now. Once I complete the lesson, I will inform you to do that tude. So you have to allocate 2 hours. You have to allocate 2 hours to do MCQ tude. Then once you allocate 2 hours, let's do the tude within that 2 hours. Otherwise, you cannot improve improve your timing. Okay. You can do MCQ questions, 2 MCQ one day, another 2 in another day, another 5 in another day. That won't help. Okay. Therefore, don't do that. Don't do that for any subject. If you are doing chemistry and biology, there will be another MCQ questions. So don't do that for any questions. Don't do that for any subject. Allocate the appropriate time. That means normally you are given 2 hours for do 50 questions now. So allocate 2 hours. Allocate 2 hours here. Allocate 2 hours here and do the questions within that 2 hours. Okay. How to do a MCQ paper? How to do MCQ paper? Suppose now there are 56 questions. 4, 6, or likewise. Normally you are given 50 questions in your exam. 50 questions in exam. Okay. Normally you have to do these 50 questions within 3 or 4 rounds. Okay. In the first round, listen to this very carefully. In the first round, you have to do questions. Normally, normally, once you look at the question, you know the answer 100%. Okay. Sometimes when you are looking the questions, you have a gut feeling, you know the question 100% correctly. So let's do the questions like that. Okay. If you know the answer 100%, so do the questions 100% correct questions. First, in your first round, do the questions 100%, you know the answer. Okay. Therefore, suppose you read the question number 1. Suppose you read the question number 1 and you know the answer 100%. 100% you know the answer. Therefore, do that question. Then go to the second question. Go to the second question. You know the answer 100%. Let's do the question. And go to the third one. Read the third one. Okay. You have a small doubt. You can do it up to 60%, 60 or 80%, but you have some small doubt. Then leave it. Leave it and go to the fourth question. If you know the answer 100% correctly, do that. Likewise, go up to 50th question. Go up to 50th question. So suppose you are suppose you have done 20 questions. You have done 20 questions. That means you know that answers 100% for 20 questions. That means you have scored 20 marks in your exam. 20 marks in your exam. No? Normally 1 mark in MCQ paper is 1 mark in your final paper. Will be a 1 mark in your final paper. So if you know 20 correct answers, that means you have scored 20 marks in your final paper. So go for the questions. Go for the questions that you know how to solve these questions 100%. Okay. Then you have scored pure 20 marks. Then go into the next round. Go into the next round. Then do the questions that you know 80%, 60% that you know sometime. So something you know, but you have a small doubt. Let's do the questions again. Let's do the questions again and take the answers. Take the answers. Okay. Then finally, now you can try the question that you don't know. You don't have any idea to solve this question. You don't have any idea to solve this question. let's do the questions finally. Let's do those kind of questions finally. Because if you try these questions initially, you won't have, actually you might be wrong, no? Because you don't know how to solve this question. No? Therefore, if you try this question earlier or at the beginning, therefore, the answer might be wrong. Might be wrong. There will be 80% to actually there will be only 20% to get correct answer. No? So the answer might be wrong. Therefore, don't try these kind of questions at the beginning. Keep them to solve. Keep them to solve at the end of the paper. At the end of the paper. Okay. So likewise, you have to go 2 or 3 or 4 rounds, then complete the questions. Okay. First, do the questions that you know 100% correctly, because you can go for those kind of questions very quickly and you can solve these questions very quickly. Therefore, you can save your time. Okay. Therefore, don't go questions one by one. Normally, children are doing like this. First, they are doing first question, then go to the second one, then go to the third one, then go to the fourth one. Normally, children are doing one by one. Don't do that. Don't do that. First, do the easiest question that you can do. First, do the easiest questions that you can do. That means you can score your marks. Okay. Then go for the next round. Then go for the next round. Once you, then you can complete the paper. Okay. Suppose you you haven't enough time to solve all the questions. Suppose you don't have enough time to solve the questions. But if you follow this way, then there will be questions. There will be actually the remaining questions might be the question that you don't know. No? Therefore, nothing to lose. No, you can do. You can take. You can choose one answer. Okay? There's nothing to lose. Okay. We can go for the last session. Last section of vector lesson. That is, no, not the last lesson. Last 2 lessons. Okay. Resultant of vector system. Write the topic, resultant of a vector system. 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 Okay. Previously, we have discussed how to take a resultant of a vector. No, not a vector. How to take a resultant of 2 vectors. No. Normally, previously we have discussed how to take the resultant vector of 2 vectors. No. If we are given 2 vectors, we know how to take the resultant force of these 2 vectors. Actually, there are several methods. The first method is vector addition principle of vector addition. We can use that principle for free vectors. Then, if we are given this kind of vector, that means tied vectors, that means vectors acting on the same point, we can use vector polygon theorem. Vector parallelogram theorem. Then those are the 2 ways of taking resultant force of two vectors. If we are given two vectors to find resultant force, now we know how to find it. Now suppose we are given a vector system. That means vector system means vectors more than there are more than two vectors. If there are more than two vectors, how to add or how to get the resultant force of that kind of vector system? How to do that? How to do that? Actually, there are two ways of doing this, finding this resultant vector. Okay, I will explain that one. The first thing is we can apply the principle of vector addition. That is the easiest way. That is the easiest way, and that is a one way of finding resultant vector of a vector system. Okay, suppose you are given, the first method is applying vector addition theorem. Vector addition theorem. Suppose you are given this kind of vectors, AB plus CD GH. There are four vectors to add. There are four vectors to add. How to do that? How to do that? Suppose you have to add four numbers, 4 plus 3 plus 7 plus 8. How to add these four numbers? How to add these four numbers? You can add these four numbers like this way. First, you can add 4 and 3, no? First, you can add 4 and 3. Then it will be 7 and plus 7 plus 8. Then you can add 7 with the result of this addition, no? Once you add the 4 and 3, the result will be 7. To that result, you can add 7, no? You can add 7 and result of this addition. That means 14 plus 8. Then finally you can add the result of this addition and the final number, no? First you can add these two, then get the result. Then you can add the third number to the result of first two, then take the result. Then you can add the final number with the result of these two. Okay. The same thing can be done for vectors. You can add 2 by 2, 2 by 2. Okay. How to do that? The first, you have to add these two. Using vector parallelogram theorem, you can, sorry, not vector parallelogram theorem, using addition of vector addition principle, using vector addition principle of vector addition, you can add these two first. How to add two vectors using vector addition theorem? You have to coincide the end point of the first vector with the starting point of the second vector. No? End point of the first vector with the starting point of the second vector. Please listen very carefully. Once you coincide these two, you will have this kind of figure. A, D. Once you coincide these two corners, then there are two free ends. One is the starting point, other one is the end point. This is the end point. No? So if you connect these two corners from a vector, this vector will be represent the addition of these two, A plus B. That is the vector addition principle. Okay. First, you have to coincide the end point of the first vector and the starting point of the second vector. Then you can connect other free ends. From the starting point to end point, there will be a vector. That vector represents the addition of these two. Then, okay. Now you have addition. Now you can remove this A and B. Okay. Now you can remove A and B and consider A plus D. No? A plus D. Now you have addition vector. Okay. Now you have the resultant vector of these two. Now you have to add the third vector to this resultant vector. Now you have to add this third vector to this resultant vector. You have to apply the same theory. If you want to add A plus B and C, what should you do? You have to coincide the end point of the first vector with the starting point of the third vector. End point of the first vector is D. The starting point of the third vector is E. So you have to coincide these two. Once you coincide, you will have this. Then there are two free ends. One is the starting point, other one is the end point. No? Now you can connect these two. From a vector. This vector represents the addition of this one and this one. Now this vector is A plus B and this vector is C. So addition of these two means A plus B plus C. A plus B plus C. Now you have this resultant vector. Addition of first three. Is this one. So you have to add the fourth vector to this resultant force. So you can apply the same theory. If you want to add A plus B plus C and D, you have to coincide the end point. End point is now F. No, end point of this vector with the starting point of this vector. So this is the end point F. This is the starting point of D. So you have to coincide F and G. If you coincide F and G, you will have this kind of figure. This is the end point of GH. Now you have two free ends. What are the free ends? First one is A. It is the starting point of A plus B plus C, and this is the free end of D. It is the end point. So if you connect these 2 points, you will have the addition of this vector and this vector. This vector is A plus B plus C. This vector is D. That means this is A plus B plus C plus D. A plus B plus C plus D. That means this vector represents the addition of 4 vectors. Okay. This is the way of taking the resultant force of these 4 vectors. How to do that? First you have to add first 2, then take the result. Then you have to add the third force into the resultant of first two, then you will have the addition of first three vectors. Then you have to add the fourth vector into the with the resultant of first three. Then you will have the resultant of fourth vector. Okay. Did you get this one? Yes. I will explain that one. This is the beginning. Okay. I will explain. There are so many shortcut methods. I will explain that one. Okay. We can add this one at one time. Okay. But this is the beginning. That's why I go for the basic. Okay. Did you understand? Did you get this point? Others? I need responses from everyone. Because this is the most important part of the vector lesson. Because most of the questions are made by this part. Only 2, 3. Others? You didn't get that one. Others? I think if you can give a response, it will be much better. Okay. I can get an idea whether you get my points or not. That means from this one. You mean this one? Okay, I will explain that one. Okay, I will explain that one. Okay, I will explain that one. Okay, I will explain that one first. Because okay, first no, I will give a note. I will give a note. Then you can draw this one. Then I will explain it. Explain it again. Okay. Okay. I will give you a note first. Then you have to draw this one. Then I have to clean the board to explain that one again. Okay. Okay. Write the topic. Resultant of a vector system. Write the topic. Resultant of a vector system. Okay. Write this under the topic. A system having more than two vectors, can be considered as a vector system. Right under that, write in a new paragraph. Determining the resultant vector. Determining the resultant vector determining the resultant vector of a vector system. Can be done using two methods. Can be done using two methods. The first method. Okay. Right under that paragraph, the first one. Using vector addition principle. Using vector addition principle. Vector addition principle. Using vector addition principle. The second method is the second thing. Using resolution method. Using resolution method. First thing is vector addition principle, using vector addition principle. The second thing is using resolution method. Okay. Write a subtopic. Finding the resultant vector. Finding the resultant vector of a vector system. Finding the resultant vector of a vector system using vector addition principle. Using vector addition principle. Using vector addition principle. Look at this board again. Look at this board again. Normally, listen to me. Okay. Actually, you can clearly see, Puta, when we apply vector addition theorem, we have to coincide the endpoint and the starting point. No? Endpoint and the starting point. We have to coincide. Therefore, when we are coincide the starting point and endpoints, we have to shift these vectors. No, we have to shift these vectors. Okay? Therefore, normally we can apply this method to free vectors. Free vectors means vectors that do not have definite point of action or line of action. Okay, point of action or line of action. Suppose you are given a vector system acting on a point. Suppose if you are given a vector system acting on a point. So this kind of vector system, you can clearly see the starting points of all the vectors are same. Therefore, we cannot coincide the starting points and the end points like this, no? You cannot apply the vector addition theorem to this kind of vector system. Actually, we can indirectly apply it, but we cannot apply directly because all the vectors have one definite point of action. Point of action. Okay. Therefore, we can apply this method. That means we can apply the vector addition theorem directly for vectors for free vectors. Free vectors means vectors that do not have definite point of action or line of action. Okay. If they do not have definite point of action or line of action, we can simply move these vectors. Therefore, we can coincide the starting point and end points freely. So these kind of things can be done directly we can do for free vectors. But if we are given this kind of vector system, that means vector system acting on a point, a definite point, then the starting point of all the vectors are same. So we cannot coincide the end point and starting point of each vectors. So we have to have separate, so some different method to solve this kind of vector system. We will learn that one. Okay. Therefore, this method normally this method is applied directly for free vector system that do not have definite point of action or line of action. Okay. Write down that one. Free vectors that do not have definite point of action or line of action. Free vectors that do not have definite point of action or line of action can be subjected to this method, can be subjected directly to this method, can be subjected directly to this method. Okay. Look at the board again. If you want to apply this method, you have to represent the particular vector geometrically. That means you have to represent the particular vector in magnitude and direction by a line segment. Okay. Therefore, the first thing you have to do is representing the particular vector geometrically. That means using a line segment. In magnitude and direction. Okay. The first thing you should do, the representing of every vector in magnitude and directions. That is the first thing. Okay. Once you represent all the vectors in magnitude and direction, then you can do this addition. Okay. Okay. Write down that one. once all the vectors once all the vectors once all the vectors are represented once all the vectors are represented once all the vectors are represented in magnitude and directions in magnitude and direction in
So can you
magnitude
repeat it again?
once all the vectors are represented once all the vectors are represented in magnitude and direction in magnitude and direction by line segments by line segments by line segments we can apply this method we can apply this method okay draw this one not the not the below not this figure the first figure only the first one okay Okay. Write down under this. Write down under this. We know how to add two vectors. How to add two vectors. We know how to add two vectors using vector addition theorem. Using vector addition theorem. We know how to add two vectors using vector addition theorem. Therefore, we can add all the vectors 2 by 2, 2 by 2. Then you can draw this down. Draw this figure. I will explain it again. First, draw this figure. When you're drawing this figure, actually, it is better if you can use 2 pens, okay? Because those are the resultant vectors. No? So, mark them in red pen. Others one are blue or black pen. Okay. You have to write this one also. AH vector, the vector AH. The vector AH is represented with vector AH represents A plus B plus C plus D. Okay. Okay. I will explain it again. Look at this. Okay, everyone, look at the board. Everyone, look at the board. Okay, as I said you earlier, now we can add these vectors 2 by 2. That means you have to add these two vectors in the first. You have to add these two vectors first. Once you add these two vectors will be omitted, and we can consider the resultant vector of it. Okay, that means suppose you have to add 4 numbers: 4, 7, 4, 5, 8. Okay, if you are given these kind of numbers to add, you can do it like this way. First, you can add these two numbers. If you add these two numbers, it becomes one number, no? It will become another one. If you add these two numbers, the result is 11. Result is 11. Now you do not want to consider these two numbers, no? You don't want to consider these two numbers. Instead of these two numbers, you can consider the addition of these two numbers. Addition. That means resultant. Plus 5 plus 8. Then what should you do? You have to add these two. What is this? This is the resultant number of this. This is the resultant of this number and the third one. And the third one. Okay. Once you add these two numbers, you can take the result of these two numbers. What is the result? It is equal to 16. It is equal to 16 plus 8. So, instead of these two numbers, now you can consider the result of these two. Result of these two addition. Okay. Now it is 1. 16. Now you can add 16 plus 8. 16 plus 8. Then it becomes a single number. It is 24. It is 24. Okay. Actually, taking the addition or determining the resultant force means, you have to reduce these 4 forces into one force, no? That is the concept, no? That is the concept. What is the concept? If you are given so many vectors and ask you to determine the resultant of those vectors, that means you have to reduce that vectors into one single vector. One single vector. You have to reduce these 4 vectors into one. Like this, no? You are given 4 numbers to add. That means you are going to reduce these 4 numbers into one number. That is the way of reducing. The first thing the first step is you have add the first 2 numbers and reduce that into one. Then you have add that result at the third number. Then reduce that into another one. Then you have add the result of these 2 and the fourth one. Then reduce into one. Okay. Did you understand the logic? Do you understand the logic? Others? I need your responses. Do you understand this logic?
So that means we add the third one to the resultant force of the first and second one.
Yes, that is the way. Third one should be added to the resultant force of the first and second one. Okay, then you will get another single force. What is that one? What is that one? This is the addition of these two. These two. Therefore, once you add these two numbers, there won't be 7 and 4, no? There won't be 7 and 4. Instead of 7 and 4, there will be 11. 11 is the resultant of 7 and 4. Once you add 11 and 5, there won't be 11 or 5. There is 16, the addition of these two. Okay. Once you add 16 and 8, there won't be 16 or 8. It becomes 24. Okay. That is the way of reducing numbers. Same logic can be applied to the vectors. If you add these two vectors, how to add these two vectors? You have to coincide the endpoint and the starting point here, B and C. This is A and this is B. So this point A, this point D. Then the resultant vector of these two is A to D. A to D. Okay. Once you add these two vectors, that means once you find the resultant vector of them, that means you can replace these two by this one, no? Resultant vector is the vector that can replace two vectors, no? Therefore, if you find the resultant of these two vectors, you can omit these two vectors and take this one only. You can erase this one. Now they are not needed. They are not needed because I have taken the resultant of these two. Okay. Now we have to add this one and this one. This one and this one. At the beginning, we had 4 forces, no? 4 forces. Now we have reduced that into 3 forces, no? 3 forces. The first is the resultant of this one. This is the third one. This is the fourth one. Now you can add this one and this. How to add this one? AD and EC. The same method. You have to coincide the endpoint of the first vector and the starting point of the second vector. This is the endpoint of the first vector. This is the starting point of the second vector. You have to coincide this one. If you coincide this one, this is A plus B. Then this is C. D equal E. This is C. Sorry, F. F. This is C. So the resultant of these two means this vector. This is A plus B plus C. Once you get the resultant vector of these two vectors, then you can remove these two vectors and consider the resultant vector only. Once you take the resultant vector, you can remove these two. You can remove these two. Because resultant vector is the vector that can replace two vectors. You can remove these two and take the resultant of these two. Now you have to add 2 forces only. The first one is this one. The second one is GH. Okay. It is simple, no? If you want to add two vectors, how to do that? How to do that one? You have to coincide the end point of the first vector and the starting point of the second vector. You have to coincide. Right? Once you coincide, you will have something like this, no? You will have this is the first vector. First vector is going like this. A, F. It is A plus B plus C. And the second vector is going like this. It is D. This point is H. I have coincide F and G. F and G. Then the resultant is these two is from here to here. A to H. What is the resultant? Addition of this one and this one. This one is A plus B plus C. This one is D. Therefore, this one is A plus B plus C plus D. Okay. So that is the resultant of entire vector system. Did you get that one? Tevunada? Okay. I need responses from others. I need responses from everyone. Yes. Different order means you means A plus C plus B plus D. Something like this. Okay. Normally, you will have the same result. You will have the same result because vector can be added in different orders. Okay. You will have same result. Okay. You can try that one. You can try that one. Because if you represent these vectors in magnitude and direction, then you can change the order. Then you will have same result. Okay. Normally in vectors A plus B, in vectors A plus B is equal B plus A. In vectors A plus B is equal B plus A. So there is no change if you change the order of addition. Okay. Okay. So this is the first method of vector addition of a vector system. Okay. Okay. Do you have any questions regarding today's lesson? Do you have any questions regarding today's lessons? Please ask me, because this is the most important part of the vector lesson. Because in your if you normally in A-level paper, if you have a question from vector lesson, it will be a MCQ question. It will be a MCQ questions. Mostly, it will be in finding resultant vectors of vector system. Okay. Normally, it is the relatively hard lesson in vector lesson, hard part in the vector lessons. Therefore, if you have a question in MCQ paper, there is a huge possibility to have that question in this part of the vector lesson. Therefore, you have to understand this part very well, clean and clear. Okay. So, do you have any questions regarding today's lesson? Thank you. Thank you. Okay. Others? Others? Okay, then okay, then we will continue the vector lessons tomorrow 3 to 6, then tomorrow 7 to 10 there will be the last algebraic lesson. I think if you can participate to that lesson, it will be very helpful for you, because I'm going to teach about logarithm functions, because that is very much need to that knowledge is required for A-level physics, some especially special questions in A-level physics. Therefore, if you can participate for that part, it will be much help for you. Okay, algebraic lesson, the last lesson of algebra. Okay, then once I complete the algebra, I plan to do measuring instrument, the theory part of measuring instrument in Monday class. Okay, so we can complete today's class, Puta. Everyone, have a nice day, and I want.
Thank you, sir. God bless you.
God bless you, Puta. Okay.